Good morning, class. I wanted to do a traditional lesson today just to give it a shot, change it up a little bit. We're going to start off with lesson 11.1. I know we kind of backtracked a little bit. We started off with 12.2, and we've been working on that for a few days. I wanted to do that because we ended with inequalities. So today's lesson should actually be a little bit easier and quicker for you guys to do when you're given a homework assignment. So we're going to start looking at linear systems of graphing, but this time it's just going to be equations, which means we aren't going to have the inequalities. And the word system just means that they're going to give us like more than one equation. So the first thing that we want to do is if they give you a point, can you plug it in and figure out if it's going to be a solution or not? Is it going to give you a true statement or is it going to give you a false statement? So first example, it says, does the point 0, 4 make either equation true? So remember, the x is going to be your 0. The y value is going to be your 4. And so we're going to plug it into each of the two equations. So I have y equals a negative 2x and y equals x plus 3. Okay, and now just substitute in your y and your x value. So our y is 4. And I get negative 2 times, I'm plugging in my x is 0. And I'm going to look at the statement now. Negative 2 times 0 is 0. 4 does not equal 0, so that's a false statement. Let's plug in our 4 here. Plug in our x. We get out the statement that 4 equals 3, which is another false statement. So it doesn't make either one true. Okay, let's look at the next example where you guys are going to plug in 5 into both of the equations. So plugging it into y equals negative 2x, our y is 5, our x this time is 2. Okay, so remember x, y, and let's read our statement. This statement would read that 5 equals negative 4, which again is not true. So we'll put a little slash through the equal sign. Let's plug it into y equals x plus 3. Okay, so we have 5 equals x plus 3. This one I can see that 5 does equal 5. That is a true statement. So yes, it's true for the second equation. Let's look at the third one that they want you to test. So if they give you the point negative 1, 2, substitute that in to each value. So y equals negative 2x. Our y is 2. Our x is negative 1. And read your statement. Negative times a negative is a positive. So I get 2 equals 2. That one's true. And then I'm going to plug in the negative 1, 2 into the equation y equals x plus 3. All right, so our y again is 2. There we go. So 2 equals our x is negative 1 plus 3. Negative 1 plus 3 is 2. So I get another true statement that 2 equals 2. So yes, it's true for both. All right, so now here down below, it says if a point works in both equations of a linear system, then that point must be the solution to the linear system. And when you solve a linear system, you find that one point that makes both equations true. So down here at the bottom, it says out of those points, which was the one that was a system or a solution to the system? And that was the last point that we plugged in. So negative 1, 2. That was the solution to the system because it was true for both of our equations. Okay, so now what we're going to do is we're going to graph both equations and see what that looks like. So I'm going to graph y equals negative 2x, which is in slope-intercept form. However, they don't have the y-intercept back here, so it's implied that it's a 0. So I'm going to go to 0. Plot my y-intercept, And then the number in front of your x is always your slope. So I'm going to make it a fraction and put it over 1. So that way I can see that I'm going to go down 2 units, and then I'm going to go right 1 unit. So I'm going to go down 2, right 1. And I recommend that you guys keep doing this until you go off your grid, as well as reversing the direction. So up 2 and back. Because the goal is we want to see where are they going to intersect. So you want to have a lot of points plotted. And then don't forget to draw your line. Okay, looking at our second equation, they have it in slope-intercept form. The only thing that they don't have is the number in front of the x written, so it's implied a 1. Okay, so again, this is my y-intercept. So I'm going to go to the y-axis at 3. And then I'm going to do a slope of 1. And again, I'm going to make it a fraction and put it over 1. This is my rise. So I'm going to rise up 1, and then I'm going to run to the right 1. So I'm going to go up and right. And then I'm going to reverse it. And I can see that overlapping point. And I truly can stop because I see where they intersect. I'm just going to draw my line. Okay. And it says, at what point did the two lines intersect? Well, this is the point -1, 2. Okay, which was the solution that we had from the previous example. So graphically, wherever they intersect, that's the point that's a solution to both of them. So it says down here, it says an ordered pair that makes a linear equation true is called a solution. The point that the two lines blank is the solution to the system. Well, that is where they intersect. Okay. And then to solve a system of linear equations, the ordered pair must work for both equations. Okay, so now I want you guys to make sure that you write these steps down for solving a linear system. Number 1 is you want to make sure that both equations are in slope-intercept or standard form. We're going to go ahead and just always put it in slope-intercept form so that we're consistent. We're going to graph each equation on the same coordinate plane, coordinate system. We're going to figure out where they intersect, and then we're just going to double check it to make sure that we're correct. So, looking at my first equation, y equals 2x. Again, they don't have a y-intercept, so I'm going to put a 0 back here. Remember, the constant number is your y-intercept, so we're going to have a y-intercept at 0. And then the number in front of the x, that's your slope. So I want it to be a fraction, so I'm going to put it over 1. I'm going to rise 2, and then I'm going to run 1. So I'm going to go up 2 and over 1. Again, I'm going to keep doing that till I run off my graph. And then I'm also going to reverse it and go down 2 and back 1. Okay, because the goal is I'm hoping that one of those points will be a solution. Now, looking at my second equation, my y-intercept is at 3, so I'm going to go up 1, 2, 3. They have a negative here, so it's really a -1. So don't forget to write that. And then you want it as a fraction, so put it over 1. So I'm going to go down 1 and then over 1. So I'm going to go down 1, over 1. I can see their common point. And I can reverse it. The goal is, can you figure out where they intersect? So I don't necessarily need to graph it all because I can already see that that's the point where they intersect, which is the point 1, 2. Right? Now, if I want to verify it, I'm going to plug it back into each one of those equations. So I'm going to say y equals 2x. So our y is 2. Our x is 1. And that gives me a true statement. If I plug it into the other equation where it was y equals -1x plus 3, plugging in my 2 and plugging in my 1, This gives me -1 plus 3, which is 2. And so I can verify that it is algebraically a solution. All right, let's try one more example. Then you can try these 3 on your own if you'd like. If you feel like you got it, then you can move on to the homework assignment. All right, so looking at this one is not in slope-intercept form, so I'm going to rewrite it. So I'm going to say y minus 2x equals -4. I want the x term on the other side, so I'm going to add the 2x over. And I get y equals, the x term comes first, then the constant. So I can see that we need to plot our y-intercept at -4. And then I'm going to look at my slope of 2, which as a fraction is 2 over 1. So I'm going to rise 2 and I'm going to run 1. So up 2, right 1. And I'm going to keep continuing that pattern until I'm off the grid, and I'm going to reverse it and then draw my line. Okay. Now your second equation was the y equals x. I'm going to go ahead and put a 1x in front of it so we can see the slope. All right, plot your y-intercept at -2. And then we're going to do a slope of 1. And again, I'm going to put it over 1 so that I know to rise 1 and to run 1. So I'm going to go up 1 over 1, up 1 over 1, 1 over 1. And then I'm going to reverse it. But we can already see where they intersect. Okay, so here's that common point of intersection. So there's our solution. Okay, so this is the x coordinate is 2, the y coordinate is 0. So we have a solution at 2, 0, and we're just going to verify it to make sure. So I'm going to use the original equation, y minus 2x equals -4. The y is 0. Minus 2 times our x, which is 2, and we're going to see, does that equal -4? So I've got 0 minus 4 equals -4, and this is true. -4 does equal -4. Okay, looking at their second equation, subbing it in, y equals x minus 2. My y is 0. Our x was 2, and 2 minus 2 is 0, which equals 0, so we have checked it algebraically. Okay, so you can try these 3 on your own if you'd like, and you can check to see if you get the solution correct. So you can pause the video and then come back. If you're like, I got this, then you're going to go to your homework assignment and get started. All right, good luck. Here's the solutions to the 3 practice problems.